Hi everybody, in this video we're looking at secant lines. We know that the average rate of change is found using 2 points. The line connecting these points on a function is called the secant line. Let's find the equation of the secant line of the graph of f of x equals 5.6x squared minus 6.4x between x1 is 5 and x2 is 11. We're going to write our answer in the form y equals mx plus b. To get started, we need 2 points. We'll find f of 5 is 5.6 times 5 squared minus 6.4 times 5, which is 108. We'll also find f of 11 is 5 times 11 squared minus 6.4 times 11, which is 607.2. Now we'll find the average rate of change between these points. So we'll have f of 11 minus f of 5 over 11 minus 5. That's 607.2 minus 108 over 11 minus 5. This simplifies to 83.2, which will be the slope of our line. Now that we have the slope, we can use the point-slope form to get the equation of a line. We'll use y minus y1 is m times x minus x1. Using 5 and 108 as our x1 and y1, we have y minus 108 is equal to 83.2 times x minus 5. We can distribute the 83.2 to get y minus 108 is 83.2x minus 416. That 108 needs to come to the right, so we have 83.2x minus 308. Now we can graph that line with our original 2 points. As you can see, the secant line touches the graph at exactly 2 points. The issue we have with the secant line is that its slope changes. If we fix one point and move the other, we'll get a different slope each time we move the second point. Let me show you what I mean. In this graph, I'm going to let A be my fixed point and I'm going to move B. Watch as I move B, my line gets steeper and steeper. The closer I am to A, the higher the slope goes up. We want to find the equation of the tangent line, which is a line that touches the graph at one point. To do that, we need to look at difference quotients, which we'll do in our next video.